Question 1 says I add 210 grams of rivets at 303 degrees Celsius made of some unknown metal to 500 grams of water at 15 degrees Celsius. The final temperature is 34 degrees Celsius. Calculate the specific heat capacity of the mystery metal. So the way I approach these is to think about the energy transfers in each case. So we've got the energy that's transferred by the metal. So for the metal, its temperature is decreasing, so I'm expecting that quantity to be negative, plus the energy transferred by the water. So the water increases in temperature, so I'm expecting that value to be positive. And when I add those two together, they should come to 0. That's because the energy that came from the rivets went into the water. So to express the energy in each, we're going to use the equation E is equal to mc delta theta, but it's also probably useful to remind ourselves that what we mean is the mass times the specific heat capacity multiplied by the final temperature minus the initial temperature. So if we remember to do it like this, then our signs will sort themselves out as we go along. So for the metal, to start off with, we've got its mass, which is 210 grams. So we're going to change it to 0.21. No, let's work algebraically to start off with. So we'll write down the mass of the metal times the specific heat capacity of the metal times theta of the metal final minus theta of the metal initial, plus for the water, the mass of the water times the specific heat capacity of the water times the water's final temperature. Of course, the metal and the water's final temperature is of the same, so I probably don't need that extra subscript in there. It's just the final temperature minus the water's initial temperature is equal to 0. We're trying to find the specific heat capacity of the metal. So in order to find that, we'd say the specific heat capacity of the metal is, first I need to move this. So as I move this term to the other side, I could make the whole thing negative, but instead I'm just going to swap around the 2 inside the bracket. So if it was theta F minus theta Wi, then if I write it as theta Wi minus theta F, that's the same as putting a negative sign before the front. So this is MW CW times theta Wi minus theta F. And then I need to divide by the terms that I had on the right multiplying Cm. So that's the mass of the metal multiplied by theta F minus theta Mi. So slightly messy to rearrange, but hopefully if I've given them all sensible names, I'll be able to put in the values quite quickly. So the mass of the water is 500 grams, so I'm going to write it as 0.5 kilograms. The specific heat capacity of the water is 4,180. Then the initial temperature of the water was 15 degrees Celsius. We're fine working in degrees Celsius because we're doing the changes in temperature, so we don't need to worry about that. Minus the final temperature of the water, so minus 34 over the mass of the metal, so that's 0.21 multiplied by the final temperature, so that's 34, minus the initial temperature of the metal, which was 303. So that should be the calculation that I do to find the value here. which gives me a value of 702. From the data in the question, 2 significant figures looks reasonable. I've got this 303 in here, but everything else appears to be to 2. So I'm going to write this as 700. This is the specific heat capacity of the metal, so it's in joules per kilogram per Kelvin.